Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to do a second problem where I'm going to use the half reaction method of balancing a redox reaction in aqueous solution where the aqueous solution is acidic. And so this one's going to be a little bit more complicated. So again, the first step you want to do is separate them into their half reactions, the redox reaction and the oxidation reaction. Let's do the oxidation. So we'll look at iron and we'll see what's happening with iron. Again, here's our mnemonic devices, Leo, Ger, oil, rig. So Leo is loss of electrons is oxidation, gain of electrons is reduction. Or oil rig, oxidation is loss of electrons, reduction is gain of electrons. So either one of those mnemonic devices should work. All right, so the first step is to identify your oxidation and your reduction. So we'll look at iron 2 plus. Iron 2 plus goes to iron 3 plus. So it's becoming more positive. So that means it lost electrons. And so oil rig, oil, oxidation is lost. So the oxidation half reaction is going to be iron 2 plus aqueous going to iron 3 plus aqueous. So that's our other half, that's our half reaction. And so the other half reduction is the other part, this part here. And so in order to figure out what's being reduced here, you'll have to use your oxidation states. So here, since oxygen here has a -2, when it's part of a substance, it's got a -2 oxidation state. So since there's 4 oxygens here, that's a total of an 8 negative oxidation state. Or I should say -8 oxidation state. Since the overall ion has a negative charge, that means that the manganese here has a +7 oxidation state. Over here, manganese has a +2 oxidation state. So it's gaining electrons. So it gains electrons to go from +7 to a less +2. So that is reduction. Gaining of electrons is reduction. So we're going to write that here. So this is the other half of the reaction. MnO4 minus aqueous goes to Mn2 plus aqueous. Okay, so we broke it into the two halves, the oxidation half and the reduction half. So next step is we want to balance the equations. The first way you're going to balance the equations is by mass, by the number of particles on each side. Okay, so I have 1 atom of iron on this side. I have 1 atom of iron on this side. That is balanced. I don't have to worry about it. Again, we don't worry about the charges. We're just worrying about the atoms itself, the particles. We don't care what charge they have, just the particles themselves. So that's normally what you're doing when you balance the equation. You're just balancing the mass. You're balancing the numbers on each side. Now over here, we have to do something different. Here I have Mn here, 1 Mn here, and 1 Mn here. That's balanced. But look, I have oxygen here. I have no oxygen here. So what I'm going to do, this is where the acidic solution comes in. We have water and we have H plus ions. So we're going to use that to balance our equation. So since we have oxygen over here, we have 4 oxygens over here, we need 4 oxygens over here. So we're going to use the water to balance the oxygen. So we're going to add 4 waters, 4 H2O liquid. So we're adding 4 waters on that side to balance the oxygen. So now we have 4 oxygens, great. But now we have 8 hydrogens on this side. We have no hydrogen on this side. So this is where the H plus ion comes in. So we're going to add 8 H plus ions on that side. And so now we have a balanced equation with respect to the numbers of atoms and elements on both sides. Okay, so now what? What's the next step? Now that we balance the mass, now we need to balance the charge. Okay, so this is where we're going to use our negative electrons. So on this one here, I have a 2 plus here, and I have a 3 plus here. So in order to balance this, I need to put a negative electron, one negative electron on this side, because the negative 1 plus the plus 3 gives me a plus 2 total, which balances with the plus 2 on this side. Okay, now we have to do this side. So what's the total charge on this side? I have a plus 8, so I have 8 H pluses, so that's a plus 8 there, but I have a negative 1. So the total charge on here is a plus 7. Okay, so I have a total of plus 7 on this side. And then this is neutral, waters are neutral, and I have a plus 2. So I have a 2 plus total on that side. So in order to balance this out with negative electrons, I'm going to have to add 5 negative electrons on this side to get this down to plus 2. So then I'm going to add over here, I'm going to add 5 negative electrons. So I'm going to try to keep those separate. Okay. So here's my balanced electron. Here's my balanced equation with the charge. Now this is balanced, right? So now I have 2 plus on both sides. This is balanced in charge. So now everything is balanced. By both half reactions are balanced. Now I'm going to add them together, but before I do, I need to make sure that the number of electrons on the reactant side and on the product side equals, so that they cancel out when I add them together. So I have 1 electron on this side, I have 5 on this side. So I'm going to have to multiply this by 5. So 5 times. So that's going to give me 5 iron 2 plus aqueous, and that's going to give me 5 iron 3 plus aqueous plus 5 negative electrons. Okay, so now everything's ready to get added together. When I add these together, the 5 electrons here and the 5 electrons here cancel out. Now I'm going to add everything on the reactant side. So here I have 5 iron 2 plus aqueous. Then the reactants on this side, so plus MnO4 minus aqueous plus 8 H plus aqueous. Okay, now I'm going to go to the products, and the products are going to be Fe5, that should be 5, sorry. 5 Fe3 plus aqueous plus, and now the products on this side, Mn2 plus aqueous plus 4 H2O liquid. And then this is my final balanced equation for this redox reaction. And so that's how you do it when you're balancing a redox reaction in aqueous acid solution. I hope this was helpful. I hope you enjoyed the video. Thanks for joining me. If you like my videos, please like, share, subscribe, hit the notification bell, and comment in the comments below. Okay? Thank you very much for joining me, and I'll see you next time.